Hi everyone. So I'm not going to repeat so many of the details. Everyone's been talking about this. I'm just going to focus on the samples that I use for the 121 class. 121 has 3 performance indicators, but I think it's already changed. So just like Yun, there's the IDE is also a performance indicator that we were measuring for 121. Then you have the comments and object-oriented programming, or OOP. So I also struggled with how to measure the IDE usage. I think Yun was a bit more creative than myself. I basically just looked at the students when they used the IDE, if they could do that. The way I sort of introduced IDE was in the first half of the semester. I did not actually ask them to use the IDE. Everyone was just using like a text editor. And the reason I had for that was because of all the syntax highlighting and then auto-completion and stuff like that. I felt that students sort of depended on those too much. So what I did was in the first part, they didn't use the IDE. And then at the second part after the midterms, then I introduced the IDE, and then we could see, I think we used CodeLight. In this case, we were using a Linux virtual machine or a Linux machine in class. And so it would basically just click on the play button. So the first part, before they used the IDE, they had to do the G++ compilation and all those steps. So here, many of them appreciated that because they could just click on the play button. And I don't think anyone really had an issue with that. The debugging was also the same. It also offers a debug feature, but what I noticed students doing was they just debugged on the command line. It was probably an effect of they weren't introduced to the IDE in the first place, so they got used to debugging their code manually. So they would do the usual cout statement to reach this part, what was the value of the variable and stuff like that. So many of them kind of did the same thing even with the IDE. And so some of them did, but they felt it was faster. I don't know, maybe it was the size of the program, it was too much work, I'm not sure. But in general, I think many of them were able to do that pretty satisfactorily. And then for measuring the second performance indicator, I used the project. So they had a project, I called it the tweet splitter. The idea was there were 3 parts to the project. In the first milestone, it was actually leading up to a point where they now used from functional procedural programming going into the object-oriented programming. And so the goal for this project was basically you're given a string, you should cut it into, I believe it was like 180 characters. That was the idea. So which is kind of like how the tweets work. So when you send a message, you have a 180 character limit, and then you have to split the text, so you have multiple messages. And so we were sort of leading into that. I think this is project 3 already. And so this is, I had all the instructions on Titanium, but then the students had to submit everything on GitHub. And so that is the sort of the project page describing each one. And then this is an example. Here I was measuring comments. So I basically taught the students how they should be commenting on your code. For example, this is the display split tweet function. It's kind of hard to see, but on your printouts, you're going to see these are the comments from one of the students' answers. They're describing, for example, what are the different parts of the code. So I was grading them on that. So part of their grade, I forgot to put in the equation, but their grade for the project looked something like your code multiplied by the design of your code, so that if you have a code that is brute force, even though it works perfectly, you wouldn't get full points for that. Plus the documentation and the style, so that basically how they commented was part of the grade they got for the project, and that's why many of the students did do the comments. This is an example of developing projects, so students were just commenting on the function perhaps, or maybe just major parts of it, missing out like other comments in the code. And then obviously the unsatisfactory is just the code without the comments, and basically the students just got grade for the coding part, but not for the documentation part. Then for object-oriented programming, this lab exercise is specifically for inheritance. I gave quite a lot of lab exercises for my class. I think I gave a total of like 14 lab exercises in my class. And we were trying to make use, thanks to Kevin and Anand's work, previously we've been trying to incorporate like a unit testing sort of framework in the lab exercises. So although there were 14 of them, which were really hard to check manually, but we basically created unit tests for each of those 14 so that while the students were programming in the lab, they could run a program SH test or something like that, and it would run the unit test and it would show them which parts of the program would fail or not. And so in the lab setting where you have one instructor and like 30 students, students would have intermediate feedback while they're programming, which we thought was very helpful. And most of the most of the help that we gave to the student was how do you interpret the unit test? Why is it failing? Maybe there's something wrong with the output or how they built the function. That was mostly like the sort of comments that they were getting. And also it helped with grading. We did like an auto grading feature, which again, if it compiles properly, if it passes all the tests, then automatically the part for the coding is checked and the instructor would just go and look at the code. Was it designed properly? Is the object inheritance, for example, set up properly, things like that. But anyway, so that was the lab exercise. This is a screenshot of the GitHub repo. It was also done through the GitHub Classroom. So when you do that, the students basically get a copy of the repository, which included the unit test. That allowed them to do the unit test in the lab. And I would just overwrite the unit test in case some students were smart and changed the unit test when I was checking. So just overwrote that and then did the unit test again to help out in the checking. That was a time saver. And so this is an example of how we were expecting students to use object-oriented programming properly. This is the display function that should be, it's encapsulated inside of the student class, for example. But this would be developing in here instead of properly inheriting, overriding and inheriting the display function. They re-implemented some parts. So instead of using just calling the parents method, they were accessing private attributes. And then you have, I don't think we had any unsatisfactory in this particular lab exercise, and that's when you see it. So if you'll notice, most of the performance indicators that I measured was really more on the programming, because I invested a lot of time on that. And so I didn't do as much of my performance indicators like in the exams and the quizzes, but we had those too. So if you want to measure your classes that way, that's also another way. So at least we have kind of a variation. So you can do the quizzes, which is like on the final exams, like Anand and you were showing. We could also do that for the lab exercises and projects as well. Thank you.